Is it visible now?
Yes. Yes, sir.
Complete screen?
Yes, sir. Yes.
Okay, wait. So, where I was basically this, I told you feed basically be preheat, then again after preheating, we again heat into the heater and we get a heater outlet temperature. We got a coil outlet temperature. What we call it as a coil outlet temperature. We maintain around 275 degrees Celsius. Correct? Now objective, see our endothermic, in FCC the reaction happens actually is the endothermic reaction, correct? So the reaction happens, objective of the reaction at what temperature? 510 degrees Celsius. How much? 510 degrees Celsius. So how do we achieve this 510 degrees Celsius temperature? Any guess? Basically it goes into the reactor riser. And that into the reactor, this reactor riser, what happens? In region we get a catalyst, right? Now I had already explained in the last session that this temperature basically we maintain a reactor outlet temperature. What? ROT, reactor outlet temperature. We give this value, we give a set value as 510 degrees Celsius. We want to maintain that reactor outlet temperature as 510 degrees Celsius. Now it will be cascaded, it will be giving control to the slide valve. This is what? RCSB, what? Region catalyst slide valve. Now the temperature into the region, how much? Around 700 degrees Celsius. How much? 700. Now 700 Celsius degree temperature catalyst. What? That fresh catalyst will come into that reactor. It will open, and suppose this temperature goes below 508. So what will happen? It will further allow to open based on the error, 2 degree error. So it will open further. So more catalyst will come. If that temperature goes above, then it will slightly close. So this is how we are maintaining the reactor outlet temperature. So this catalyst will come, but catalyst automatically will not go at the top, right? So for that purpose we are giving one lift steam. What? We give here a lift steam for the lifting purpose. So lift steam basically takes away, the V2 of this RR reactor region, that 97% of the reaction will happen into the reactor riser. What? 97% of reaction occurs in reactor riser. Where? Occurs in reactor riser. Reactor riser. This riser basically a vertical kind of a portion, straight pipe kind directly here continuously, and this reaction basically happens into the gaseous form. So whatever the feed we are giving, that directly it will not go into the liquid form. So what will happen? Through the we are giving atomizing steam. So atomizing steam basically it will be MP steam. So atomizing steam will be giving, it will atomize, then will be having the feed nodules. Through the feed nodules it will form that feed will go into the atomized form, and then once it gets connected to this catalyst at a higher temperature, cracking starts immediately. Now, and this cracking will happens throughout the reactor only. Once this cracking happens, reactions happen, we'll have a cyclones over there into the reactor. We'll having the stripper into the stripper. The reason I'll tell purpose of stripper, basically it goes into the cyclone. BSS chamber will be, vortex separation system will be there. Then after that it will go into the cyclones. Here single stage cyclones will be there. Two cyclones basically here in UOP division, and we have 2 single stage cyclones. Through that it will get separated. That cyclone purpose basically to separate the catalyst from the reaction mixture. So catalyst comes below and the gaseous forms, the gaseous vapor mixture goes to the top, from top to the reactor vapor line. This is the reactor vapor line, it goes into the main column, correct? So whatever the reaction mixture after the reaction we get, it is feed into the main column. This is we call as a fractionator. now the what happens to the catalyst? Catalyst definitely will it will not be 100% separation into the cyclones. What will happen? It falls below the stripper section. In stripper section we are giving here stripping sections will be there. What will be there? Stripping section will be there. Here we are giving stripping streams. Stripping stream basically MP stream to strip off whatever the hydrocarbon entrapped hydrocarbon is there that being stripped out, and this also goes into the main column. Rest whatever the catalyst temporarily carbon temporarily deposited on the catalyst, it goes to the region and it is being maintained with the label. Suppose this reactor label we are maintaining 40%. So based on this is be called a spent catalyst slide valve. It will open, correct? So this spent catalyst slide valve will open based on the label we are maintaining. Continuous this circulation will happen. So catalyst will come here. Then on the catalyst temporarily deposited carbon will burn off here into the region we are giving basically air from where we are getting. We have a main air blower, we'll having an air blower and we are feeding here, and that feed almost 65 kNm cube per hour we are giving that air flow, and it is getting in contact with this spent carbon catalyst, and it will burn off. Then fresh catalyst will go again back to the reactor. So this is how we are establishing the RR cycle. RR cycle. Is it clear?
Yes. Yes, sir.
How we are establishing the RR cycle in FCC? Any doubt till now?
So one doubt, sir. You said about the endothermic reaction rate.
Correct.
So where does it take place?
See, after feed this is a reactor, correct? I told you na.
Yes.
After feed we get a feed, after heating feed we get at a temperature of 275 degrees Celsius, and the reaction happens at 510 degrees Celsius. That temperature from where we'll get? See, FCC is fluidized catalytic cracking unit. We want catalyst also to be get contact into the feed. That catalyst will come at a temperature of 700 Celsius. Once that gets contacted with the feed, its temperature will go to the 510 degrees Celsius immediately, and the moment it comes into the contact, reaction occurs. That's why I tell, once it start traveling into the reactor riser, in the reactor riser is a vertical portion of pipe, and then 97% of the reaction happens. So basically all over the reactor this reactions happens. Is it clear?
Yes.
So basically reactor riser reaction start taking place into the reactor riser into the vapor phase only, and 97% to 96 to 97% of reactions happens here only. Okay. So I'll come to the reason part only. Whatever air burned off, so air we can add immediately. Here we'll have a DDSB double disc slide valve. We'll like slide valve we are having SCSB, RCSB. Also we'll have a DDSB here. So we are maintaining, there is a reason RR pressure we are here. RR we are maintaining, basically RR DP we are maintaining. Reactor region DP around 0.3 kg per centimeter square we are maintaining RR DP. So based on yes, please. Any questions, Vinay?
No, sir.
No? Okay, some noise came, that's why I thought someone is asking. Okay, so RRDP we are maintaining basically based on that, whatever air we are giving, based on RRDP, this DDSB will open and will allow excess air, burn 700 degrees Celsius air, will go to the orifice chamber. Here pressure drop will happen. In the orifice chamber is basically a equipment, vertical equipment, basically. Okay, details equipment it is I'll tell sometimes other because it will take lot of time. So here basically orifice chamber, there is a pressure drop, and then after that it goes to the CO boiler, because basically it's a 700 degrees Celsius. Now we cannot expose that 700 degrees Celsius temperature directly to atmosphere. It is harmful to the atmosphere environment also, and unnecessary releasing that temperature heat, now it is a waste. So we want to recover that heat, so that heat recovery is being done basically into the CO boiler, and waste heat recovery boiler will be there, WHRS. Then after that it will goes to the from there some acidic gases will be there, SO2 and all will be there. So it will, one section will be there, FGDU, flue gas desulfurization unit. So after that basically here we are scrubbing off the gases, we are spraying the water over there, we are giving caustic also for maintaining the pH. Then after treating then it will goes to the atmosphere. So we don't want to allow harmful gases to goes into the environment. Mostly CO2 only we routed, rest are SOx and NOx we don't allow. Minimum we are maintaining. We have an online analyzer, so we keep monitoring. If due to any process upsets and all, if any problem coming, that analyzer will give us alarm. Okay, this kind of problem is coming, you have to look into it. Then accordingly we take our action. So after treating, this flue gas we route into the atmosphere. In case of emergency and all, stack will be there. Any problem comes, FGD, some problem comes, so what will directly be routed at that time momentarily. So at that time directly stack for safe, because we will not be having any option for that. So directly 600-700 degrees Celsius temperature. That is rarely only startup time or any emergency comes, at that time only goes like that. Okay, so is it clear for the region portion side?
Yes, sir.
Okay, now coming back to the top portion of reactor, we get reaction mixture, and we feed it to the bottom. Now from the bottom, I told you now different product we are withdrawing. So basically I'll come from the bottom we get a CLO. So CLO basically will have a slurry pump. What? We will have a slurry pump. From slurry pump what happens? It will go to preheat exchangers. I told you right? It goes to the preheat exchangers. So that preheat exchangers, it goes to the tube side, it will go, and cell side that feed will go. Correct? If feed I to our state up after feed pump, this is what we got. The cell side feed will go, and we are heating that, we are getting this slurry after cooling. Then it goes to steam generator for further temperature reduction and heat recovery. We are generating HP steam. After HP steam, it goes to the one top of the manifold will go. So from manifold we route it to the column again as a part of pump around. So pump around we give a bottom quench, then tray 5 we are giving, and tray 3 we are giving, tray 3 bottom quench, tray 5 like that, we pump around we are giving, so maintaining the temperature. And rest all whatever the product is there, from there will go to the CLO cooler and all, and from there it will go to the product. So this is how bottom product is being we are withdrawing. Simply CRO also we are withdrawal we are taking, we are giving a preheat, after recovering a preheat we get a steam gen also, MP steam we get it. Then after that again this one again we give it a pump around here, right? CRO pump around for maintaining the call. Simply HCO also, HCO we get a one will go for HCO PA, HCO pump around, one another is HCO product. HCO product basically goes to HCO stripper, we strip off, then from that HCO, then coolers and all will go, from there it will directly goes to run down as a diesel, run down, or directly we send it to the DSDS or DST unit for a hydrotreating purpose. Similarly LCO also we get as a LCO pump around and LCO product. Similarly from the top we get a LPD, low pressure distillate will go here, overhead condenser will be there, big condenser will be there, it will condense. After condensing it will go to the receiver, from receiver part of that will send it to the main column as a reflux for maintaining the column profile. Rest all low pressure distillate, it will goes to the HP receiver into two fill form. One is the top product, top portion will goes to gas stream. There are two streams we get, one gas stream, one liquid stream. We can tell is that liquid stream will goes to the HP receiver. HP receiver basically high pressure vessel from here. From there it goes to the stripper to goes to the DB column, DB noiser columns, and from DB column we get LPG and CRN we send it to FCC and ST for the treating purpose, and from FCC and ST we give that CRN crater naphtha to MS pool for blending, and the LPG we give it to the Marox for further treatment, then it goes to the bullets for the selling purpose. So and the top product gas, so from the top it goes to the KOD, the wet gas compressor will be having two big compressors. So wet gas compressor KOD, in KOD we knock out the liquid, because in compressor we cannot allow the liquid to go because it will damage the compressor. So at any cost we should not allow liquid to go. So whatever the gas stream will go comes to the KOD. After KOD it will goes to the compressor. From compressor it will compress. Here pressure will be 1.6 0.65 to 1.7 kg, it will compress to some 13-14 kg, 13-40 kg pressure. Now after compression again, after coolers and all, it comes to the HP receiver only. Through the condensers or all, from again the gas circuit from HP receiver will goes to the absorbers, primary absorber, secondary absorber, like somewhere we call it as a primary absorber, sponge absorber. After the recovery, some CRN be given a primary absorber and HCO be given a sponge absorber for recovery purpose of the CRN, okay, and lighter components, LPG and all. Then after that, that gas goes to the sponge absorber to the SRO unit, sulfur recovery unit, for further treatment. So after SRO unit, it goes after this is a sour ATG we get from that sponge absorber. Then sour ATG will go to the SRO, it gets treated, it will become the sweet ATG. Sweet ATG comes back to the gas plant. We'll having the gas plant. Gas plant purpose basically is to provide the fuel gas to all the units which are having heaters for the burning purpose. Suppose we are having heaters like here, so heater are necessary somewhere. We are that fuel we are burning here. We are basically fuel gas. That fuel gas, this is basically ATG what we are generating after treating, we are burning. Treatment purpose basically environmental effect is there, environmental norms is there. We cannot allow harmful gases to go directly into the atmosphere. So that ATG comes to the gas plant. From gas plant we use it and other consumers use it. So that is all about the small process flow diagram I tried you to brief. So is it clear for you guys?
Yes, sir.
Any doubt? Once open your videos.
So what is the catalyst that we use?
That details we get is basically catalyst component, different components are there. Basically zeolite based. We'll get a clay also. One binder will be there. Matrix will be there. It is a mixture of 4 components. Okay. Zeolite, matrix, binder, clay. And details I will explain. Zeolite you might have read in your BTech time.
Yes. ZSM5.
ZSM and all. One type of that, but that not exactly that we are using. So it's a mixture FCC. Basically, it's like a very fine powder only, like a clay. Sands will be there now. It will look a white sand. It will look like exactly white sand. So sometime I'll get opportunity. If you guys any plan is there for you guys to visit VR Vizag Refinery?
No, sir.
No planning. So how will people will be collecting your certificates and submission of report online? All will be online only?
Yes, sir.
Anything told by HR?
No, sir.
Nothing.
He said all will be in online version.
If you ever get opportunity, you discuss with the HR. If you want to visit, discuss with Nitish. If he agrees, I can make arrangement for visiting of FCC unit. So whatever that queries are, they are not visible. See, what you are seeing into the presentation, like you cannot relate actually that FCC units and all is a huge unit. And simply like what I have told, like I tried to give you a brief introduction. But even though lot of things there, lot of learning is there, it's not for you, for ourselves also. There are lot of things that we need to learn also. It's a ongoing process. But if you have a exposure directly, if you are seeing the RR reactor region and the equipments, you can relate better. But anyway, this session is going to be useful, I guess, for you guys. Okay, so then some other time I'll explain a lot of, let's say it's been almost 1 hour, right? FCC operation explained to you guys, troubleshooting one more session I'll try to take. Meantime, you guys start, right? Have you guys started making report and all?
Yes, sir. Actually, we had collected some samples from my seniors.
Okay. They are working here in VR.
We prepared. Yes, sir. No, sir. Actually, they had done an internship last year in VR, HPCL VR. So we had taken some of the information and we have prepared some report.
Okay, you guys, that
for introduction part.
you guys once share, I'll see what if there is any changes, I'll let you know. I'll try to correct it. Meantime, Have you guys used any time Visio software?
No.
No. Try to make process flow diagram. Visio, try to download. It's a good software. Microsoft. I guess it is paid only. You check it if you get from seniors and all. Any help from them? If you try to use that, it is the very good software for making process flow diagram and all. So try to one make block. At least what I have told you. Try to make a block flow diagram. Try to relate that, and you mention into the report. If you are not able to make a soft drawing, what you can do? You make a hand drawing and add in that, no problem. But it should be neat and clean. And take a pic of that and add in that, okay? Whatever you are reading from the process flow, make a hand sketch and add in that. So next session I'll try to take some other day. I'll let you know. So today, as of now, we'll end this session. Is it okay? Because still lot of things are there. If I'll continue, it will take 3-4 hours minimum to go through one by one. Explaining catalyst itself will take half an hour like that. Then process details, equipment telling itself will take lot of time. And then case studies or troubleshooting, one troubleshooting explaining will take half an hour like that. So in one day I cannot explain you all, but I'll try to connect, okay? So Lohit, Grace, Sarup, shall we end the session?
Yes, sir.
Okay. Any doubt? Any questions if you have, you can ask, no problem. The 5 minutes I can give you for the question answer session till now what I have told you. Okay, then we'll end the session. Okay guys, then thank you so much.